Hi there, good morning. So in today's video, I'm coming to explain using GeoGebra how you are going to clone a triangle, how you are going to find the sum of interior angles of a triangle, how you are going to draw an isosceles triangle, and how you are going to draw a right angle triangle, and finally, how to prove the Pythagoras theorem, right? So follow up and let's start. So the first thing that we are going to do is to learn how to clone a triangle. First of all, what is a cloning? Cloning means to make a replica of something, to do the same thing, right? So before we can clone a triangle, first of all, we have to create a triangle. So this is our triangle. With this, you can use the input field to input the points, but there are a lot of tasks. Then we are having a limited time. I want this video to be as short as 20 minutes, right? So inputting the field would delay quite a bit. So you can select your points using the pointer over here. Then you join them using the segment, right? So I'll join them to form a triangle. Tap, then you join, tap, then you join, right? You tap on the point, then you join to the other point, then you tap it. Now there's not yet a polygon yet, so you have to activate the polygon. So after activating the polygon, we tap and we join, we tap and we join, tap and we join, right? Now we've been able to form a polygon. The next thing is we want to do a replica, clone this triangle that we've done. We are having two ways of cloning a triangle. I'm coming to show you the first way, right? So before that, let's do the angles within the triangle. The interior angles within the triangle. Okay, to do that, you have to activate the angle. You come here, then you activate angle, right? After activating angle, go clockwise to select the interior angles, right? Clockwise, just like the way the clock moves to select the interior angle. Now we are done drawing the triangle. We want to clone this triangle. The first method of cloning a triangle is by using a vector, right? So we come here, then we select our vector. After selecting our vector, you point to any part of your graph, of your graphics, right? Then you tap and you stretch, then you tap. We've created a vector. That is the vector U. Then the next thing that you're going to do is you come here, then you select translate by vector, right? After tapping on the translate by vector, you have to tap on the object that you want to translate to get it. Then you tap on the vector here. You come to the algebra side, then you tap on the vector. You can clearly see that I've been able to translate that vector. Do you see it? Good. So with this, we use the move tool. We use the move tool. Let's go. Let's go down. You can see that I've done a replica, right? Now with this, I can deactivate the U, the vector, and deactivate the D and what E. So you can see, let's see whether it is indeed a replica or a clone of the triangle that we drew by measuring the interior angles. So this is what we call similar triangles. When we say two triangles are similar, it means that they have the same length and also they have the same interior angles. Do you get it? So you can see that the interior angles of the first triangle and the interior angle of the second triangle are both the same, right? You can clearly see. And what makes this a perfect clone is that when I move my original, it also moves the clone. When I move the original, so as the interior angles of the original is changing, it also makes the interior angle of the clone to also change. So that is the first way we can clone a triangle, right? Another way of cloning a triangle is by doing this. Another way of cloning a triangle is, first of all, we use our points. Okay, first of all, we come to line, right? Let's draw a line. So we draw a line. Let's draw a line. right? We've gotten a line. Then let me position the triangle well so that I can clone. So we clone the original triangle, right? We don't clone the clone. Do you get it? So now I'm coming to clone the original triangle. I'm coming. I want it to be in a position. Okay, this is okay. I'm coming to clone the original triangle, this triangle, right? This is the original triangle. So after drawing the line, I'll use the compass tool here. I'll use the compass tool here. Then, so you activate the compass tool from this side, right, to this side. Then you move it and you center it at what? F. Do you get it? Then I will activate the compass tool from here to here from here to here. Then still I'll center it at what? B. What we are doing is we are creating what a replica, right? So we can see that the distance BE is from F to this line, right? So it means that I can do an intersection here. So from B to E is the same as from F to the point that will be formed here. So I come to my point, then I look for intersect. Then I can input my intersect here, right? Good. Now I can let go of the circle created here, the bigger circle. I can let it go. Not this one, the bigger circle. I can now let it go, right? Now the next thing that I'm going to do, you know that from here to here give us what? Give us this. So I have to finally do from this side to this side. You get it? We did from this side to this side to get the length that is here. Then we did from this side to this side to get the length that is here. Finally, we want to get to know what point, we want to know the B points here. You get it? So how do we do that? We use our compass tool. We use our compass tool. Then from here to here. Then we center it. We center it on what? H. You get it? So the points of intersection here is the same as the points of intersection here. You get it? Then the next thing that we are going to do is to draw an intersection, right? So we know that we have an intersection here. After drawing an intersection, we use the line segments, right? You come here, you activate the segment, then you can join them to form the triangle. You tap, then you join. You tap, then you join. Right, now we are done. All that we have to do is to make it a polygon. Now we've made it a polygon. So these are the two ways that you can draw a clone of a triangle. We can deactivate the lines that helped us, right? We can deactivate the lines that helped us. We can deactivate the lines that helped us. Then the point G, right? Now we've been able to clone, we've been able to clone the triangle. So you can see that if I move this side, both the original, moving the original, but it is also moving the two clones, right? One was created by circles and one was created using a vector. You get it? So this is how we get to clone a triangle. In our next video, I'm going to show you, saying in our next video, at this point, I'm going to show you how to draw an isosceles triangle. So we are done with the cloning, right? With this, you can paint it or color it, but the main thing is we've been able to done. We are done with the cloning. Good. So the next thing that we are going to do is that, okay, somebody might ask, how sure should I be if indeed I've drawn the right thing? One way of being sure that indeed what you've drawn, they are all clones. Let's check this. The exterior angle here. You can see that the exterior angle there are all the same, 341.42. And it is the same for all of them. You get it? Good. Now let's draw isosceles triangle. What is an isosceles triangle? An isosceles triangle is a triangle that has two sides equal and two of the interior angles are also equal. So to draw an isosceles triangle, we are having three ways, but in this case, I'm going to show you two. because of time constraints, right? In my next video, then I'll show you more. So to do that, first of all, we can create a line, right? We come to this part, then we activate a line. So after creating the line, the next thing we are going to do is to come here, then we select, no, let's come here, then we select, or come to the input field, then let's type perpendicular, right? Perpendicular, perpendicular bisector, or let's type bisector. Bisector, you can see perpendicular bisector, right? Let's type this perpendicular bisector, right? From the point J, from the point J, from the point J to the point K, right? So that is the perpendicular bisector, right? Then the next thing that we are going to do is we've been able to draw the perpendicular bisector. The next thing we are going to do is we can draw let's pick the intersection here. Points. Let's pick the intersection here, right? Good. Now the next thing that we are going to do, we can use our compass tool. So using our compass tool, we measure from here to here to draw a circle, right? Then we center it on L. You get it? So we will get the point that is formed here. Then we come to this side. We come to this side. Then we look for intersection, right? Then we point here. Now our isosceles triangle is almost ready. We use our line segments to join these points together. To join these points together, right? To join these points together, right? Good. Now we are done. We are done with. We are done drawing our isosceles. So we can erase the helping lines. We can erase the helping lines. Can erase the helping lines. So after erasing the helping lines, we want to measure to see. First of all, we have to form a polygon from this, let me see. Let me see. Yeah, polygons on this. Then let's measure them in serial angles. Let's measure them in serial angles. I want to check something. In serial angles. No, this will measure the external. So let's do, always remember it is clockwise. So clockwise, just like the way the clock moves. Okay, you can see that. You can see that we have two of the interior angles being equal, right? If two of the interior angles are equal, it means that this length and this length are, this length, let's activate this length, are equal. So this length, we can show object properties to get to know the length of that length, that side. So label, name and value, right? 9.9. Then you come to this side, label, name and value, right? 9.99, sorry, 9.9. So clearly you can see that we've been able to draw our isosceles triangle, right? This is one way of drawing the isosceles triangle. Good. Another way of drawing an isosceles triangle is by drawing a circle, right? How do we draw the isosceles triangle? To draw the isosceles triangle, you just need a compass, right? Then you draw a circle. After drawing a circle, all that you have to do is to just use your line segments, right? Line segments, we come here, we activate our line segments. Sorry, we come here, we activate our line segments. Then we join from this point to this point, right? Then we can join from here to any point on the circumference, because we know that any point at all becomes a what? Becomes a radius. That is one of the properties, right? From the center to the circumference is a radius, right? Then finally, you can join from this point to this point. So you can see that within a triangle too, we can form an isosceles triangle. Sorry, within a circle, we can form an isosceles triangle. Then we join them finally so that it becomes a polygon. A polygon. Now we can delete the circle. Then we can delete the circle. Then we have our isosceles triangle. How do we know it is isosceles triangle? By measuring the interior angles, right? So this is 97. So two of the interior angles must be the same for us to confirm that it is an isosceles triangle. For us to confirm that it is an isosceles triangle. Now you can see that this is 41.12, this is 41.12. So this is how we draw an isosceles triangle. You get it? Good. So in the next, I'm going to show you how to draw a right angle triangle, right? How do we draw a right angle triangle? Good. How do we draw a right angle triangle? To draw a right angle triangle, we first have to uh, draw, our, you can, a line, right? You draw your line. Then after drawing your line, After drawing your line, you can, you draw a circle using the compass tool. So we come here, then we draw a circle using the compass tool. Right, so we tap here, and we tap here. Okay, we have to create a point there first before. Okay, we come to the circle tool. We tap here, then we tap here to draw our, good. So now we've drawn our circle, we centered it at Q. Do you get it? So to know that it is, sorry, it is a right angle. This is what we are going to do. You see that there's a point of intersection here. You have to activate the intersect. Then we have the intersection here, right? The next thing that we are going to do is to use our compass tool. Let's create a smaller dot somewhere here. Let's create a dot, a point here, right? Okay, let's create it somewhere here. Okay, let's create it here. Here will be okay. Then we activate our compass. So from here to this point, right? Then we center it on T. Figure it. Then we'll do the same thing from here to here. Then we center it on what? S. You can clearly see that there's a point of intersection between the two circles. You see that? Then we activate our intersection. Then we identify the points of intersection. We identify the points of intersection, not this one. We identify the points of intersection here. You get it? So the line that will pass through, or the segment that will pass through Q and V, becomes a perpendicular line. Do you see that? A perpendicular line. So we can say that we want a segment, so segments, right? On the input field segment between 2 points, that is V, capital V, and capital S. Sorry, capital Q and capital Q, right? Now you can see this. So let's clean the lines, the helping lines, that is the circles. Let's clean them. Okay. So now we can use a line segment to join from this side, right, up to this side, or up to this side, or up to any side at all you want. Do you get it? So up to this side, then we deactivate S. We deactivate S, then we deactivate what? U. They are done helping us. Then we deactivate the line Q1. Okay, the line Q1. Okay, so we deactivate the point T. Then we close this side now with what? A segment from here to here. Now we've drawn our right angle triangle, right? Then we close it up. We close it up with a polygon. This is how you can draw a right angle triangle. How do we know it's a right angle triangle? If one of its interior angles, if one of its interior angles is 90 degrees, then it is a right angle triangle, right? Then you can see that this interior angle is 90 degrees. So we've been able to draw our right angle triangle. The next that we are going to do is to find the sum of interior angles. So let me help you so that we all find the sum of interior angles. Let's complete everything here so that we can find the sum of the interior angles. So now we are done with the interior angles here, right? Let me move them outside so that you can see the angles. So this is O, this is somehow like P, this is somehow like the sine, right? This is the interior angles. Now we want to find the sum of the interior angles, right? To find the sum of the interior angles, you just have to come to spreadsheet. Do you get it? You activate the spreadsheet will come. After activating the spreadsheet, the next thing that you are going to do is that you are going to type in the input field, right? But before you type in the input field, you have to come to the bottom here. Then the symbols are there. So I can see the O. Let's look for the O symbol. What is the O symbol? This symbol, the O symbol. Okay, it is not here. Okay, let's use our norm. Then it should be the normal O, right? Then we come here, we look for that P symbol. This is the P symbol. Then we look for this symbol, right? We identify the symbols. We know that the sum of interior angles is to add the interior angles all together, right? So we'll put an addition sign between them. We get it. Then we press enter. You get it. So after pressing enter, this is it. Coming. Okay. So when you tap on this, then you record on the spreadsheet. They will all go to the spreadsheet, right? We tap here, then we record on the spreadsheet. We will all go to the spreadsheet. Then we want to know. Let me rename this. Okay. Let me rename this to. Uh, let me rename this to. Let's say V. Okay. Okay. Now I've changed it to V. Okay. So this is what I want to do now. Now let's do Y, Y, P, then this sign. Then we use the addition sign to join them. Addition sign to join them. Then we press or enter. Okay. Okay, now it has come. Do you see that? It has come. Good. So now all that we have to do is what? Is we have to record that on our spreadsheet. We get to record it on our spreadsheet. So now let's focus now on our spreadsheet. So we know that the sum of the interior angles is what? Okay. Now let's focus on our spreadsheet. So we come here. The y is the 90 degrees. The b come, okay. So you tap on this red button to show them, right? So it means that 90 plus 68.82, when we add all the sums together, we are going to get 180 degrees, right? So this is how we use the input field and the spreadsheet to find the sum of interior angles of a triangle. Well, I hope it is clear. Now, the last thing I'm going to show is how to prove the Pythagoras theorem. How do we prove the Pythagoras theorem? And to do that, I'm going to need a new window. How to prove the Pythagoras theorem. How to prove the Pythagoras theorem. So now let's start by proving the Pythagoras theorem. To prove the Pythagoras theorem, we would need what? A circle. I'm saying a circle. A triangle. What does the Pythagoras theorem say? It says that the length squared, the breadth squared, or the length squared, when you get the length and you get the height, when you square them individually, is equal to what? The square of the hypotenuse, or the opposite squared, the adjacent squared is going to give you the hypotenuse also squared. So now let's form our triangle first. So we point it out to get our triangle, right? Now we'll join them up using a segment. We join them up using a segment. So this is the segment that I've joined them up using a segment. I've joined them up using a segment. So this is my triangle, but before I can make it a polygon, I have to activate the polygon, right? You come here, you activate the polygon. Then the next thing that I'm going to do is when I square the hypotenuse, graphically, it's supposed to be a square. If I square the base, graphically, it's also supposed to be a square. If I square the height, graphically, it should be a square. You get it? So that is what we are going to do next. We are going to draw a square. To do that, come here, activate on the polygon, or right click on your mouse. Then you come to regular polygon. Tap here and tap here, right? How many vertices do you want? We want a square with 4 vertices. We activate, we come here, we come here. How many vertices do we want? 4 vertices. You see, if you go anti-clockwise against the direction of the clock, this is what will form. But I want to go in the same direction of the clock, so we don't do that, right? We do this and this instead. Do you get it? 4. Now, before it will come down, we are going in the direction of the clock. Always remember that. Then, good. So as you can see, we've been able to form our squares. You get it? The next thing that we are going to do is that if all the squares, if the square here is able to fit in this square, and the square here is able to also fit in this square, then it means we've been able to prove the Pythagoras theorem, because this length squared, that is the entire region here, and this length squared, that is the entire region here, should be this length squared, that is the entire region here. It means that graphically, everything here should come here, and everything here should also be able to fit here all together. So let's prove that and see. To continue, we are going to activate the line. We come here, we activate the line, this side to this side. Then we activate the line also here, this side to this side. You can see we are having an intersection, right? Yes. Look for your intersection at this side, then find the intersection here. After getting the intersection, you can do away with the lines. You can do away with the lines. Now we have the intersection. The next thing we are going to draw or do is to draw polygons, right? Polygons. So we activate the polygons. From this side to this side, we make it a polygon. from this side to this side, from this side towards this side. Good. So we are having a polygon. We continue to form the polygon from this side to this side, from this side to this side, from this side to this side. Always remember to close your polygon from this side to this side, from this side to this side, from this side to this side, and from this side to this side. Okay, we didn't draw this well. From this side, okay, since we've made a mistake, let me correct it, okay? Made a mistake. Okay, so let's draw from here to here, from here to here, and back from here to here. Now we come from here to here, from here to here, from here to here, from here to here, to here, and from here to here. Then we have from here this side, from here to this side, and finally from here to this side, right? Now we've drawn our polygon. Do you get it? So let's change the colors of the polygon so that we wouldn't get confused. We come to the move tool, then we come here, then we right click, then we come to object properties, right? Then we come to color, then let's change it to pink. Then let's increase the opacity, right? Now let's come to this side. Let's change it to, let's say, orange. Then, pardon me, this is more like orange, yeah. Then we come to this side. Then we increase the opacity. Let's choose the color blue. Then we increase it, right? Now we come to this side. Let's choose the color, let's say green. Then we increase it, right? Now let's come to this side. Let's choose the color blue. We've already chosen blue, so let's choose the color red. Then we increase the opacity. You get it? Good. Now we are done creating the needed things we need. You get it? Like I said before, to prove it, we're supposed to show that the square here, that is the entire thing, will fit, is going to fit this square together with this, right? Good. Now there are some things that we have to deactivate to make our work look neater, right? So the ones with the A1, delete them, right? The A1, B2, H1, make sure you are not delete, deactivate them, sorry. Deactivate them so that the work becomes neat. So we deactivate all of them to get a clearer and a neater work. Now, good. So the next thing that we are going to do is this. We are going to be using what we call a slider, right? You come here, you activate your slider, then you point on any part, right? On any part. Let's name our slider Z. That is the name. Then the minimum should be from 0, right? The maximum should be from 1. Then the increment will be from 0.01, right? Then we click OK. So this is our slider. You get it? Slider helps us to do animation, to cause movements in the diagrams that we've done. But so far, we've not added any effect to it, so it doesn't show. You get it? The next thing that we are going to do is to draw a vector, right? We come here, then we activate our vector. Then the vector should be from J. But before we draw the vector, right? Sorry, before we draw the vector, we're supposed to do this. Come to the input field and type J, right, plus bracket open. So Z. The Z means your slider, right? Then you want to move. You remember in vectors, when we say J minus B, it means that I want to move from B to J, right? But if we say B minus J, it means I want to move from J to B. So I want us to move from J towards B. So we do what? B minus what? J. Do you get it? Then let's press on what? Enter. You can see that we've created a point that can move from J towards B. Do you get it? Good. So Out of that point, you are going to create a vector. So creating a vector, the vector will be from the J to the K. Do you get it? So we've created a vector. So you can see that the vector moves and decreases. Do you get it? The next thing that we are going to do is to what? Come to translate by vector. After clicking on the translate by vector, you tap on the thing that we want to translate. Do you get it? After tapping on the thing that we want to translate, you come to the algebra and then we point on the vector. Do you get it? Now you can see that we've created something. We've created, let me see, seems there is a problem. Incoming. So as you can see, we continue from here. One discovery that I discovered is that if the triangles are not of the same, are not the, if the base and the height is not of the same length, we wouldn't be able to prove it. That is it. So I had to go back to do some form of corrections so that the base, so when you are doing it, make sure that the base, right, and the height is of the same length. So as you can see now, when I move the slider, it fits perfectly, right? But if the base is longer than the height, then it won't fit. You get it? Good. So now let's continue. Now to do the next thing, we want to move this also to the circle. Sorry, also to this bigger one, right? To do that, this is what we do. We want to move J plus the slider name, right? Then we want to move from where? We want to move from coming. Since we made a mistake somewhere. Mhm. Okay, okay. So now let's continue. I want to move J, so I come here as an input field. I type J plus Z, then bracket. I want to move, I want to move J to E, right? So I'll do E minus J, right? Then I'll press enter to get it. After pressing enter, I have to select a vector, right? So after selecting the vector should be from J, right, up towards then L. Do you get it? The L here. Whenever we do that input field, it creates a label. So check the label. Then your vector should join the initial J to that new label. You get it? So now we are moving together. Okay. Then what we are going to do next is to translate. So we come here, we translate. Before we translate, you tap on where you want to move, right? Then the vector that you created, right? Now, if we move, you see it's fixed perfectly. So this is what we want to do. Now, the next thing that we are going to do is, the next thing we are going to do is to move this side, right? To move this side to this side, D. So we come to the input for J plus brackets. So I have to Z. Then we want to move from, so D first minus what? J. D minus J means JD, right? In vectors, JD. So we are moving from the J to D. Then when we press enter, you could see that a vector will come. This is the new vector M, right? Then we use our vector. We join from J to M. Do you get it? The next thing that we are going to do is to activate the translate by a vector. Then we tap on the point that we want to move. Then we tap on the vector that was created, right? Good, good. So now you can see that we can move them together. The next thing that we are going to do is to move the orange side, right? So we want to move the orange side to where? To C. So all that we have to do is we come here, J plus Z bracket, right? We want to move J to C. So which one should come first? C, letter C should come first, right? Minus what? J. So C minus J is the same as JC, J to C, right? If you learned, yes, if you learned your vector, so you learned your vector well, you'll be able to figure this out, right? So this is what we do. A new vector will be created. A new vector will be created. Let's come down to know the vector. That is n, right? So let's look for where n is. This is where n is. I've seen it. So I've seen n, right? We select the vector tool. It will move from J to n. Do you get it? Then the next thing that we are going to do is to translate. We tap on where we want to move. Then we point on the vector. Do you get it? Good. Now, as you can see, we've been able to fix them clearly and nicely. The next thing we are going to do is to move this side, right, to the center. How do we do that? To do that is quite simple. This is what you are going to do. You are going to use the compass tool to draw a circle, right? To draw a circle using this side. So you can see we've drawn a circle, right? Oh, sorry, not this side. You draw a circle using this side. As you can see, we've been able to draw a circle. Then you center the circle at C. Do you get it? Then we mark the intersection. We mark the intersection. We mark the intersection. Now we can deactivate the circle, right? Now we want to move this part to this side, right? We want to move this part to this side. So our origin is what? J. Do you get it? We come here, J plus Z bracket, right? We want to move um we want to move this side to this side. So the point here is what? Point O, right? Good. So O minus what? J, right? Let me see what was created. Mm, I'm gonna, okay, I think, so we come to the input field J plus Z. Then we point on, so to do that, all that we have to do is, first of all, we punch on our input field. I had to check something. We put using from the GeoGebra app, right? We point from the input field. As we want to move, now we want to move the H to where the O is. So where the O is, plus together with a slider, right? So we are moving it together with a slider. Okay. Then the point that we are moving is what? From O minus H, right? That is H. We get this. We press on enter. Oh, okay. 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 Now the slider is here. Okay. Okay. So let's continue. So we point H plus Z, that is our O, minus H, right? That is HO. And press on enter. A point will be created. That is the point Q that is here. We draw a vector from H to join us the Q. Then we translate it. Just like I said, you tap on the thing you want to translate, then you activate the vector. You get it. Now you can see that we've been able to form it. You get it. So we've been able to prove that everything within this square, together with everything within this square, be able to fit in this square. What it means is that when we square this length, which is the entire thing here, and we square this side, which is the entire thing here, it is equal to the square of this side. So the boxes here, everything here can go into this, together with everything you're going into this. Hence, we've been able to prove the Pythagoras theorem, right? Good. So let's make our work nicer, right? By deleting these lines. So we delete this, not delete them as such, but we hide them, right? We go to the show there to hide it. We hide them. Okay, let's tell you. So we hide them. Good. Okay. Then we hide these symbols too. Okay. So this is the last thing that we'll be doing. You can see that we've been able to prove the Pythagoras theorem. Let's put this thing on animation, right? Let's turn the animation on. You can see that it is showing the Pythagoras theory. You can increase the speed by coming to the sliders here. Then we increase the speed to 3, or let's say let's use 4, right? You can clearly see that the speed has increased. So this animation shows that we've proved the Pythagoras theorem. So this brings us to the end of today's video. Bye bye.